After more than 40 years, the Voyager 2 spacecraft has crossed a boundary. NASA successfully averted a problem. Its engineers had sent a wrong signal to Voyager. Voyager 2, the distant spacecraft that has been journeying through the far reaches of our solar system and beyond since its launch in 1977, has just transmitted a discovery so confounding, so unexpected that it threatens to rewrite parts of what scientists thought they knew about deep space physics. Decades after it left the familiar territories of our planetary system and plunged into the mysterious vastness of interstellar space, it has encountered something that seems impossible. A phenomenon that not only defies existing models of the interstellar medium, but raises deep questions about the nature of cosmic boundaries, magnetic interactions, and perhaps even the structure of space itself. Before we start, smash the like and subscribe buttons for more updates. For years, Voyager 2 has been drifting through the silent ocean of interstellar space, far from the Sun's dominion, where the solar wind no longer holds sway and the influence of our star wanes to nearly nothing. Since it crossed the Heliopause, the boundary marking the end of the Sun's influence, scientists have been monitoring its instruments with anticipation, eager to see how our local bubble interfaces with the larger galactic environment. But nothing could have prepared them for the moment when Voyager 2's magnetic field sensor began reporting data that didn't add up. It wasn't just an anomaly or a glitch. It was a pattern, reliable, measurable, and deeply out of place. The spacecraft drifting in the interstellar medium began detecting structured magnetic fields, sharp coherent alignments of force lines that simply shouldn't be there, not in the way they appeared. According to decades of astrophysical theory, the interstellar magnetic field is supposed to be relatively uniform on large scales and turbulent on small ones without rigid structure over narrow regions. Yet, Voyager 2 was recording neatly aligned bands of magnetism, layers that seemed to pulse with energy, and stranger still, shift in ways that suggested some kind of rhythm. These weren't random fluctuations. There was intention in the way they changed. Intent that nature, at least as currently understood, wasn't supposed to exhibit in a region of cold near-empty space. Further compounding the mystery was the detection of a faint plasma wave synchronized with these magnetic field structures. Plasma waves are not unusual in space. They ripple throughout our solar system and beyond. But the characteristics of these waves, the frequency, amplitude, and alignment matched nothing Voyager 2 had previously encountered. Not even during its crossing of the Heliopause sheath, where solar and interstellar influences clash. The implication: something is actively shaping this region of space, sculpting its magnetism and plasma with precision and consistency that cannot be explained by any natural process currently understood. Scientists pored over the data, rechecking calibration, reviewing past measurements, looking for any indication of equipment degradation that might explain the results. But Voyager 2, though old, remains remarkably stable, and all signs pointed to the data being real. What makes this even more baffling is the region of space where Voyager 2 currently resides. It's thought to be a relatively unremarkable part of the local interstellar cloud, a zone not associated with strong magnetic structures or any stellar remnants that might influence its environment. One of the most startling implications of this discovery is the possibility that the interstellar medium is far more dynamic and structured than previously believed. Until now, it has been viewed largely as a diffuse collection of particles and fields shaped occasionally by passing stars or supernova remnants. But the sharpness and regularity of the magnetic structures Voyager 2 encountered suggest a level of complexity more akin to engineered systems than random flows. Some scientists are even daring to speculate whether these structures could be remnants of ancient cosmic phenomena, forgotten shock waves from extinct stars, or more provocatively, evidence of processes not yet discovered in astrophysics. This discovery also throws into question the nature of the Heliopause itself. For years, it was treated as a relatively clean boundary, a bubble blown by the solar wind into the interstellar gas. But the structured magnetism beyond it suggests that the Heliopause might not be a static shell at all. Instead, it could be an active interface, a permeable membrane where the solar system continuously exchanges material and energy with the galactic environment. If true, this changes our understanding of cosmic insulation, the idea that the solar system is a sealed-off environment protecting its inner planets from galactic influences. Instead, it may be more of a semi-open system entangled with its surroundings in subtle and complex ways. Further down this speculative path lies the possibility that these structures represent a deeper ordering principle in the galaxy. Something akin to magnetic scaffolding. Such a scaffolding, if it exists, could serve as highways for energy transfer, particle movement, or even information moving across the galaxy in ways humanity has never imagined. If interstellar space is not a chaotic void, but a finely tuned environment with layers and currents, then much of astrophysics will need to be rethought from the ground up. And then there's the philosophical weight of this discovery. Voyager 2 was never expected to return messages that would shake the foundations of scientific understanding. It was launched to explore the planets and give humanity its first close-up views of Jupiter, Saturn, Uranus, and Neptune. Its mission, in the minds of many, ended with those planetary flybys. But the spacecraft kept going, crossing new frontiers, whispering data back to Earth from distances so vast that a signal takes over 18 hours to arrive. That this humble machine, moving silently into the abyss, has now stumbled upon something this profound speaks to the serendipity of exploration and the boundless complexity of the universe. As scientists delve deeper into the data, they're also revisiting Voyager 1's records. Though the two spacecraft entered interstellar space at different points in time, a comparison of their findings might yield deeper insights. Curiously, Voyager 1 reported irregular magnetic data during its crossing of the Heliopause, though not quite the same as Voyager 2. At the time, those anomalies were dismissed as transitional turbulence. Now, in light of the recent findings, those irregularities are being reinterpreted, possibly as a prelude or counterpart to the structures Voyager 2 is now mapping in greater detail. The implications stretch even to the search for extraterrestrial life and intelligence. If space contains ordered magnetic frameworks that stretch across vast distances, could they serve as channels for communication or even transport? For decades, scientists have pondered whether intelligent civilizations, if they exist, might use natural features of the universe, gravitational lenses, pulsars, or magnetic structures as part of their technology. The existence of highly structured magnetism beyond the Heliopause introduces a new candidate. Whether these formations are natural or artificial remains unknown, but the very fact they exist challenges assumptions about the uniformity of space and the randomness of cosmic processes. What makes this discovery particularly poignant is that Voyager 2 is operating on the edge of death. Its power supply is dwindling and only a few of its instruments remain operational. Every byte of data it sends now is a miracle of endurance. And yet at the end of its journey, it is revealing to humanity a truth we weren't prepared for. That the emptiness between stars may not be empty at all. Instead, it could be a domain of hidden order encoded with patterns filled with invisible architecture that shapes the behavior of matter and energy on galactic scales. The notion that interstellar space could host structures previously invisible to us introduces a new frontier not just of exploration, but of understanding. This isn't just a matter of curiosity. These structures, if widespread, could influence the journey of future spacecraft, deflect cosmic rays, affect star formation, and potentially even play roles in galactic evolution. Understanding them isn't just a theoretical pursuit, it could be vital to humanity's long-term ambitions in space. Furthermore, if Voyager 2 has found one such region, how common are they? Are these magnetic bands scattered throughout the galaxy in a mosaic of overlapping zones? Are they relics of past cosmic events or ongoing manifestations of unknown forces? Do they move, grow, evolve, or stay frozen over eons? With only one tiny probe exploring one tiny spot, the answers are tantalizingly out of reach. But even this one glimpse is enough to shake cosmic complacency. This discovery challenges the boundaries between astrophysics, plasma physics, and cosmology. It hints at undiscovered interactions between magnetic fields and charged particles that operate at scales and intensities beyond what current models can replicate in laboratories or simulations. Theories once thought esoteric about magnetic reconnect-ion, plasma instabilities, or cosmic string analogs are being pulled back into the discussion, re-evaluated under the harsh light of real data from the frontier. For the engineers who built Voyager 2, the moment is almost surreal. A spacecraft designed with 1970s technology with less processing power than a pocket calculator has pierced the veil of the sun's influence and delivered a revelation. It's not merely a triumph of endurance, but a reminder that bold exploration, even when launched with limited tools, can yield discoveries that more modern risk-averse missions might never reach. This event has also inspired renewed calls for an interstellar follow-up mission. If Voyager 2 with its primitive instruments can uncover such a profound mystery, what might a modern probe equipped with high-resolution sensors, AI-assisted diagnostics, and propulsion systems designed for interstellar travel uncover? There's now a growing urgency to send a new generation of explorers beyond the Heliopause. Not just to map the space between stars, but to understand what exactly resides in it. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us what are your thoughts on Voyager 2's impossible discovery in deep space. We want to hear from you. Thank you for watching and see you next time.